Here we are in the well-ventilated hood. Now we can see how extraction is physically done with a separatory funnel. Notice that since I have added the basic aqueous solution, that I now have two layers. An organic layer comprised of ether on top, in which you can see all of our indigo is dissolved because of the blue color, and below, the aqueous layer. Now, all of that tranexamic acid is not in this aqueous layer already. A lot of it is still up here in the organic.
Hello there.
Hello.
Sorry to interrupt you. You know we're dressing.
As I was saying, all of that tranexamic acid is not yet in the water layer. Most of it is still up there in that organic layer. So how are we going to get it all into the water layer? Well, we're going to shake it. When you're shaking the SEP funnel, proper technique is very important, because pressure builds up. Now there are two reasons that pressure builds. One, you're shaking and putting a lot of energy into volatile substances like ether, so they vaporize. But another big reason is because tranexamic acid wants to be more soluble in water. And what does that mean? That means that it's at a lower energy when it is dissolved in water than the energy it takes to dissolve it in ether. So when this happens, when it moves from ether to water, energy is going to be released, because it's more favorable for it to be dissolved in water. It's a lower energy environment. The bonds it can make are stronger, or there are more of them. For this reason too, heat is going to be evolved, and we are going to get more pressure in our gases in the SEP funnel. That's why we have to vent it very often, and venting has to be done in the hood. When shaking, we should put a cap on it, and when we hold the SEP funnel, we should hold two fingers, at least this is how I do it, around the top, putting the cap into the palm of your hand and holding it this way. Then with my right hand, I can control the venting. So just shake a little bit and vent. Shake a little bit and vent. Now you should shake and vent until you stop hearing this squirting sound. I'm about done. That means that the amount of tranexamic acid that wants to go into water has gone into water. We have reached an equilibrium between the two phases in terms of tranexamic acid. Now I'm going to collect the water layer containing tranexamic acid, we hope. Before I do that, I want to remove the top cap. Otherwise, a vacuum will form and you will get bubbles coming up through the SEP funnel, which will upset the separation. Let's see what that looks like. Okay, let's try it with the cap on. I'm not draining very quickly, am I? It's kind of just trickling out. And this is open all the way. In fact, it's pretty much stopped at this point. Basically, a vacuum is formed. Now I'm going to open it back up and try to drain again. It's only open part way, and we can see already that it's draining very quickly. Is the separation of the layers obvious to you? Before this layer separation point gets to the bottom of the step funnel, I want to stop it, or at least slow it down considerably. Then I can let the remaining water layer trickle out, and right before the ether layer gets to the point of exit, just cut it off. Now I have a water layer containing tranexamic acid, and an ether layer containing indigo. Now that we have these two solutions, all we would have to do is rotovap either one of them down to get our solid isolated compound back. And that is how you use the separatory funnel to extract. Or wash.